Alright, so today we're going to continue our lesson on LeChat, and we've talked about changes in concentration. We've also talked about changes in temperature and determining whether something is exothermic or endothermic. Today we're going to talk about changing pressure and changing volume. They're actually the same thing, but they are opposites. So we're going to take a look at what we have today. And I'm going to start by telling you that pressure is largely determined by the amount of gases we have on the different sides of this double arrow. And so I'm going to count the amount of gases we have. So the first thing I expect you to do is to count the number of moles of gas on each side. And the way we can count the number of moles is we're not so much worried about the formula, we're really worried about the number in front of each formula. And so you can see that there's 2 here. This implies that there are 2 moles of gas A, whatever gas A is. Okay, you guys see that too? Okay. Now, are there any other gases on the left side of this double arrow? Yes. There is one more located right there. If I were to add all of the gases on the left side, it would be 2 plus 1 for a total of 3. Can you count the number of gases on the right side? How many are there?
1.
There is 1. Why does D not count? It is a solid and not a gas. And so if I could actually total everything together, I can say that there are 3 moles of gas on the reactant side, but there's only 1 mole of gas on the product side. Are we okay with this? Now, what does this have to do with anything? Well, it turns out that when we have a stress, you can have a stress that increases the pressure or decreases the volume. They essentially do the same thing. The idea here is that there's less space. I call this idea crowdedness. You feel more crowded. Imagine if I were to take this room and shrink it in half. I just said, this half of the room you cannot sit in, and so we're going to squeeze all the desks into this half of the room. Are there still the same number of people? Yeah. But there's less volume, and therefore higher pressure. You feel more crowded. LeChat then is going to predict that we want to reduce this crowding. We essentially want to favor the side with less gas. I would rather have less students if my classroom was smaller. Yes? So in this particular equation, which side would it favor? The left side or the right side? In this case, the right side. And why does it favor the right side? Because that is the side that has less gas. Is it always going to be on the right side? No, that's why you have to count the number of gases on each side. But what's the net effect then when I shift to the right? A and B will go down, and C will go up. How come D is not on the effect list? Because it is solid. Solids and liquids do not change their concentration, and so they have essentially no concentration effect. How was that? Well, what about the opposite? Well, what if I were to say decrease the pressure? This would be the same as increasing the volume. This is like making my classroom bigger. If I took all of your desks and I moved you into the gym and I spread you out, that would be essentially increasing the volume. This is reducing the crowding. Now remember, we were in perfect equilibrium, and so we want to do the opposite of this, which means I want then to do what? What is the LeChat principle going to predict will happen? We want to then do the opposite, which is increase the amount of people, which is to try to fill that extra space. There's too much space now. If we take our class and move it into a really large space, it's hard for you to talk to your partner. You can't really interact with your partner. And so it favors having more students. This is kind of why the PE classes are so large. Have you noticed that the PE classes have larger class sizes? And like 50 or 60 students. Part of that reason is because there simply is a lot more space. So to fill that space, you can put more students there. Unfortunately, it makes it challenging for your PE teacher to control all 60 students, which is why they don't. So we see students in the hallway. They really need like 2 PE teachers for all 60 students. But it makes sense that you can fill that extra space because there's just lots of room. So you could put 2 classes there. So ideally what would happen then is if I were to move to the gym to do some cool experiment there, because there's so much room, it would make sense to get another chemistry class to join us there, and we could have a little joint activity in that extra space. Does that make sense? So, which direction will it shift then? To the side with more gas. That would be to the left. Net effect here then is that A and B go up and C goes down. Now let's be clear here. We're shifting to the right because it has okay. So the shift is not simply left or right, it's because that side has less gas or it has more gas. If the equation was different, then it would shift in a different direction, but it would always shift towards the side that has more or less gas, depending on which one is opposite to the change. Questions for me? Yes?
Why is there 3 gases on?
Alright, so we have a example problem here. And the first thing I'm going to have you do is I'd like you to count the number of gases on each side. So, I'd like you to count the number of gases on each side. And just go ahead and like write it kind of like near it. Like this has this many gas on this side, this has many gas on the other side. Okay, so check in with your neighbor, see if you have the same number of gases. How many gases are on the left side?
4.
There are 4, 1 plus 3. We're only counting the coefficients in front. We don't really care so much about the small subscripts. So there are 3 or 4 gases on the left, and how many on the right?
2.
There are 2 gases on the right. How was that? Not that bad. Okay, so I have some further questions for you. I'm going to tell you that this reaction is endothermic. I'd like you to write the word heat or the word energy on the correct side of the equation. Okay, let's check in. So we've identified that the heat should be located on the left. Okay, and if I'm cooling the reaction, am I adding or removing heat from the system? I'm removing heat from the system, and so I need to do the opposite of this, which is to add heat. And so the opposite then is to heat up the system again. Do we want to go towards the energy or away from the energy if I want more heat?
Towards.
I want to go towards the energy and generate more heat, right? And so I want to shift to the left in this case because it goes towards my energy. Going that side will then release that energy to make heat. How did you do? Okay? If we think of heat as cash, removing heat is like taking away money from you, right? So, do you need to upgrade or downgrade to do the opposite of, you need to downgrade to get more cash back. We need to go towards the side that is a downgrade. So from the high energy side to the low energy side, net release is cash. How'd you do? There is an additional question on here. If the reaction were heated, which direction will it shift? Okay, check in with the neighbor. See what you get. What'd you get? To the right. Excellent. Okay. I'm going to add an extra one here. I'm going to call this one...
An extra question.
Extra question. I'm going to call this one D. You ready? I'm going to increase the pressure. This is a pretty common stress. I'd like you to talk with your partner about what is the opposite of increasing the pressure. What's the opposite? And do we want more gas or less gas?
More gas.
Okay, chit chat with your partner about what's the opposite and do we want more or less? Okay, so the opposite of increasing the pressure is to then decrease the pressure. And decreasing the pressure favors the side with less gas. The more gas you have, the higher the pressure. The less gas you have, the less your pressure. But which side has less gas? Remember, this side on the right side has 2 gases, and the one on the left has 4 gases. So this one actually favors a shift to the right side. Why the right side? Because that is the side with fewer gases.